In this video, we'll be talking about array blocking queue. Array blocking queue class is one of the implementation of blocking queue. Array blocking queue is an array-backed bounded queue. By bounded, it means that the size of the queue is fixed. Once created, the capacity of queue cannot be changed. Attempts to put an element into a full queue will result in the operation blocking. Similarly, attempts to take an element from an empty queue will also be blocked. Boundness of the array blocking queue can be achieved initially by passing capacity as the parameter in the constructor of array blocking queue. This queue orders element first in, first out. The head of the queue is that element that has been on the queue the longest time. The tail of the queue is that element that has been on the queue the shortest time. New elements are inserted at the tail of the queue, and the queue retrieval operation obtains element at the head of the queue. Array blocking queue supports an optional fairness policy for ordering waiting producer and consumer threads. With fairness set to true, the queue grants threads access in, first out order. Array blocking queue example. We will be implementing a producer-consumer example with array blocking queue. We'll be creating two runnables, one for producer and other for consumer. Producer will be putting numbers to the array blocking queue using put. Consumer will be taking numbers from the array blocking queue using take. Both put and take are blocking, so if the queue is empty, the thread will be blocked, and similarly, if the queue is full, put will be blocked. Now let's implement this example in IntelliJ. So let's create a class, and the class name is array blocking queue example. And create public static void main. Inside public static void main, we'll be creating an instance of array blocking queue. So array blocking queue integer array blocking queue is equal to new array blocking queue of capacity 5. Now let's create a runnable producer is equal to and inside the runnable I is equal to 0, and while true array blocking queue dot put I plus I, and print out added I. And after each add, we want to wait for 1 second, so let's have time unit dot millisecond dot sleep 1000. It's complaining about the exception handling, so let's surround this with try catch. Try and then catch. Catch. Interrupted exception, IE, and IE dot print stack trace. So this is our producer. Now let's create a runnable for our consumer. So runnable consumer will be taking it from the queue. And in this case, it will be while true. So this is a forever loop. And integer call So this is the integer value which will be holding in the pool, the value which will be taking out from the queue. So pool dot array blocking queue. Pool is equal to array blocking queue dot take. And afterwards we'll be printing out pool plus pool and time unit dot milliseconds dot sleep and 1000. And the same, we'll be putting this under the try catch block. Catch exception IE and IE dot print stack threads. Now let's call these threads, and through executor service we'll be initiating through threads. So executor service dot or executor service is equal to executors dot new fixed thread pool of 2 and executor service dot submit producer and executor service dot submit consumer and executor service dot shutdown. So let's go through the example again one more time. So first of all, we are creating an instance of array blocking queue with a capacity of 5. Then we have a producer array blocking queue dot put. Put is a blocking. So if the array has a full capacity, then it will wait until some of the value is being removed, so that it can put the value again into the queue. And afterwards it print out added, and then it wait for 1000. And here I have a consumer queue, and this consumer queue is taking from the array blocking queue, and this is also blocking. So it will block, and it will print out the value of the integer, and it's sleeping for 1000 milliseconds. So let's see, maybe consumer, what we can do is that instead of waiting for the 1000 milliseconds, let's have it wait for 20 milliseconds so that we can see an example where it has taken more than array blocking key is putting into the queue. Now let's run this example. So you can see that added and pulled, added 2, pulled 2, added 3, pulled 3. So it is basically going in the sync order. It is adding all these values in, and then values are being taken away by the take thread. Now let's put a before this consumer thread is awakened. What we can do is that we can make the poll call. Before poll call, we can just have this thread wait for more than a millisecond or sleep, and then let's have it wait for like 3 seconds, and then see the behavior. Or maybe more than 3 seconds. Let's wait it for 10 seconds. So now you can see that it's adding 1, 2, 3, 4, and 5, and now it is waiting for those items to be removed because the capacity is 5. And after pulled, it was able to add 6, and then now it is in a sleep mode for 10 seconds our pull thread. So now it pulled 2, so it added 7, and this loop will continue on. So the maximum capacity of the array blocking queue will never increase beyond 5.